Hello, welcome to my channel. In today's video, we are going to find a general solution to the differential equation y exponent dy over dx equal to e exponent x. This is a very interesting one. Is it a differential equation? Yes, because it contains a derivative of an unknown function, that's the dy over dx. So we can find the general solution. So come along as I find solution to this differential equation. So first of all, what we need to do is to find a limit of both sides of this equation so that we can drop the derivatives. So I can say taking limit of both sides, So I'll have ln y exponent dy over dx is equal to ln e exponent x. Remember, the law of logarithm says that if you have log x base a exponent s exponent n base a, it is equal to n log s base a. So from here we can say this is dy over dx ln y equal to x ln e. So have dy over dx ln y equal to, so anytime that you remember ln is a log of a natural base e, and a log to the same base is always 1. So we can say this is 1. So we'll be left with only x there. We can multiply both sides by dx. Then we'll have dy ln y equal to x dx, which I can rewrite as ln y dy equal to x dx. So we have managed to separate the variables with the dy to one side with its variable y and the dx to one side with its variable s. What we need to is to integrate both sides to find the general solution. So we can now integrate both sides. So we can say the integral ln y dy equal to integral x dx. So we can easily integrate this part of this ln y. How do we do that? We need to use integration by part to integrate that. This can be rewritten as the integral ln y times 1 dy equal to integral x dx. So I'll pull this out, integral ln y times 1 dy, and integrate by parts. So integrating this by part, I'll let u to be equal to ln y and v prime to be equal to 1. So now I'll find my u prime. That's the differential of ln y is just 1 over y. And to find v, we integrate it, and the integral of 1 will be equal to x. And remember, integration by parts is that the integral of u v prime will be equal to uv minus the integral of v u prime. So we can say the integral, remember this is ln y times 1 dy will be equal to our uv. U, remember, is ln y, so this will be y, please, with respect to y, so the integral will be y. So we'll multiply this by this, that will be y ln y, then minus the integral of vu prime. And what's our v? Our v is y, and our u prime is 1 over y. So we have y times 1 over y dy. So we can say our integral of ln y, this times that is still the same thing, dy will be equal to y ln y. When y multiply 1 over y, we'll be left with only 1. So 1 dy. So the integral of ln y dy will be equal to y ln y, and the integral of 1 with respect to dy will be equal to 1, so minus y. So we can conclude that the integral of ln y dy is y ln y minus y. So we can just come and substitute this in place of this and say that the integral of this will be y ln y minus y equal to, and the integral of x, remember, will be half x squared, then plus our constant of integration. So we can bring this here. We have y ln y minus y, then minus half x squared equal to our constant c. Our y is common here, so we can pull it out and say y bracket ln y minus 1 minus half x squared equal to a constant c. Then this becomes our general solution to our differential equation. I hope this will help someone. If it does, remember to subscribe to the channel, like, comment, and share my videos, because these are the only ways you can help promote my channel and I can record more mathematical content for you. Until we meet again, this is Rich Brain.